Hello learners, welcome to this video lesson. In this video, we are going to discuss how to solve problems involving permutation. Before we proceed with the discussion, let us set our objectives. At the end of this video, you will be able to define permutation, apply the formula for permutations to solve problems involving the arrangement of objects in a particular order. Analyze real-life situations that involve permutations and determine the appropriate method for solving them. Let's recall what is permutation. Permutation is an arrangement of objects in a definite order. It is an arrangement or listing in which order is important. Take note that permutation and combination is not the same. Since in permutation, order is important, while in combination, order is not important. Meaning to say that if you have an arrangement A, B, C, D, it is not the same as arrangement B, C, D, A. Now, let's talk about the types of permutation. There are different types of permutation. In this video, we will discuss and solve permutations of objects taken all at a time, taken R at a time, distinguishable permutation, and circular permutation. Taken all at a time. Permutation of n objects taken all at a time is a type of permutation in which all objects are included in the arrangements. The formula for this type of permutation is P, the quantity n, n quantity equal n factorial, where n, the total items or objects in the set, exclamation mark denotes taking the factorial. Example number 1. In how many ways can Susan arrange 6 potted plants in a row? This problem is an example of permutation of objects taken all at a time. So, we will use the formula permutation is equals to n factorial. We will only need the value of n, which is the number of items or objects in the set. Now, let's identify the objects and the number of them in the set. In this case, the objects are the 6 potted plants. Hence, n will be equal to 6. Apply the formula P is equals to n factorial. By substitution, substitute the variable n with 6. We will have P is equals to 6 factorial. Then, expand or take the factorial of 6. 6 times 5 times 4 times 3 times 2 times 1 is equal to 720. Therefore, there are 720 ways Susan can arrange 6 potted plants in a row. Example number 2. How many possible arrangements can be formed from digits 0, 1, 3, 5, 6, 7, and 9, taken all at a time? Now, identify the objects and the total number of them in the set. In this case, the object or objects are the digits 0, 1, 3, 5, 6, 7, and 9. There are 7 of them, or there are 7 digits. Hence, n will be equal to 7. Apply the formula for the permutation of n objects taken all at a time, which is P is equals to n factorial. By substitution, substitute the variable n with 7. We will have P is equals to 7 factorial. Expand or take the factorial of 7, it will be equal to 5040. Therefore, there are 5040 possible arrangements. Next, taken R at a time. Permutation of objects taken R at a time is a type of permutation in which not all objects are included in the arrangement. This is the opposite of the previous type of permutation, which is taken all at a time, since in this case, we will not include all objects in the arrangement. The formula for this type of permutation is P is equals to n factorial all over the quantity n minus r quantity factorial, where n to the total items or objects in the set, r to the total items taken for the permutation, and exclamation mark denotes taking the factorial. Example number 1. Bernard wishes to form his ATM PIN code from digits 0 to 9. If he has to consider only 4 digits, how many possible PIN codes can he choose from? This problem is an example of permutation of objects taken R at a time. Identify the objects and the total number of them in the set. In this case, the objects are the digits 0 to 9, and those digits are digit 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have 10 digits, hence n will be equal to 10. Then since he has to consider only 4 digits, r will be equal to 4. Apply the formula P is equals to n factorial all over the quantity n minus r quantity factorial. By substitution, substitute the variable n with 10 and r with 4. We will have P is equals to 10 factorial all over the quantity 10 minus 4 quantity factorial. Get the difference of the value in the denominator. 10 minus 4 is equals to 6. So, we will have 10 factorial all over 6 factorial. Expand. After getting the factorial of 10 and 6, simplify, it will be 5040. Therefore, there are 5040 possible PIN codes Bernard can choose from. Example number 2. 8 people join the food making contest. How many ways can a first, second, and third placer be rewarded? Identify the objects and the total number of them in the set. In this case, the object or objects are the people joining the contest. The total number of them is 8. Hence, n will be equal to 8. Then since we need the first, second, and third placer, r will be equal to 3. Apply the formula. By substitution, substitute the variable n with 8 and r with 3. We will have P is equals to 8 factorial all over the quantity 8 minus 3 quantity factorial. Get the difference of the value in the denominator, which is 8 and 3. We will have 5. Thus, 8 factorial all over 5 factorial. Get the factorials of the value 8 and 5. After getting the factorials of 8 and 5, simplify. It will be 336. Therefore, there are 336 ways that the tree placer can be rewarded. Distinguishable permutation. Distinguishable permutation is the permutation of a set of objects where some of them are alike. The formula for this type of permutation is P is equals to n factorial all over P factorial Q factorial R factorial, where n is the total items or objects in the set. P, Q, R are the objects that are alike, and exclamation mark denotes taking the factorial. Example number 1. How many distinguishable permutation can be made out of the word probability? In this problem, the object is or are the word probability. In the word probability, there are 11 letters. Hence, n will be equal to 11. Then, get the objects that are alike in the word probability. In the word probability, we have 2 B's and 2 I's. After getting the objects that are alike, use the formula for the distinguishable permutation. Then, by substitution, substitute the variables with its corresponding values. Get the factorials of the values. 11 factorial all over 2 factorial times 2 factorial. 11 factorial is 39,916,800, while 2 factorial times 2 factorial is 4. Simplify 39,916,800 divided by 4 is equal to 9,979,200. Therefore, there are 9,979,200 distinguishable permutation that can be made out of the word probability. Example number 2. How many permutations are possible with all the letters of the word ellipsis? In this problem, the object or objects are the word ellipsis. The word ellipsis have 8 letters. Hence, n will be equal to 8. Get the objects that are alike. In the word ellipsis, we have 2 E's, 2 L's, and 2 S. Using the formula for the distinguishable permutation, P equals to n factorial all over P factorial Q factorial R factorial. By substitution, we will have P is equals to 8 factorial all over 2 factorial 2 factorial 2 factorial. Get the factorials of the values. 8 factorial is 40,320. Meanwhile, 2 factorial times 2 factorial times 2 factorial is 8. Simplify. 40,320 divided by 8 is equal to 5,040. Therefore, there are 5,040 distinguishable permutations in the word ellipsis. Circular permutation. Circular permutation is the permutation of objects when they are arranged in a circular pattern, or is the number of ways that a number of items can be arranged around a circle. The formula for this type of permutation is P is equals to the quantity n minus 1 quantity factorial, where n is the total items or objects in the set, exclamation mark denotes taking the factorial. Example number 1. In how many ways can 5 people be seated around a circular table? This problem is an example of circular permutation. So, we will use the formula P equals to the quantity n minus 1 quantity factorial. In this type of permutation, we only need the value of n, which is the number of items or objects in the set. Let's identify the objects and the total number of them in the set. In this case, the object or objects are the people, and there are 5 of them. Hence, n will be equal to 5. Apply the formula. By substitution, substitute the variable n with 5. We will have P is equals to the quantity 5 minus 1 quantity factorial. Get the difference of 5 and 1. We will have 4 factorial. Expand or take the factorial of 4. 4 times 3 times 2 times 1 equals to 24. Therefore, there are 24 ways 5 people can be seated around a circular table. Example number 2. In how many ways can 10 student council members be seated in a round table during a meeting if the student council president and secretary must always sit together? In this problem, the objects are the 10 student council members. Hence, n will be equal to 10. However, since there is a certain condition that the student council president and secretary must always sit together, they will be counted as 1. Hence, n will be equal to 9. Apply the formula for the circular permutation. By substitution, we will have P is equals to the quantity 9 minus 1 quantity factorial. Get the difference of 9 and 1, we will have 8 factorial. Then get the factorial of 8. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 40,320. Therefore, there are 40,320 ways that the members of the student council can be seated around a round table during a meeting.